Hi, Stuart here. Today, goodness, the 5+5+5 principles of development. Here's the moniker that I inflict on my teams constantly. If you clean up as you go, your code will never give you woe. So let's talk about how to avoid woeness. So the continuous delivery folks have these as being core aspects of good system design. They have it in a different order, but it didn't make a very good acronym, so I've reordered, and I call it CCAMS. So cohesion, coupling, abstraction, modularity, and separation are the five areas that we want to focus on from a continuous delivery point of view, and they're core to domain-driven design as well. You can see that we've supplied some references. This is going to be a very reference-heavy presentation because there are good things. If you don't watch Dave Farley's Continuous Delivery channel on YouTube, I strongly advise you to. It's an excellent channel, and the book is worth every penny, written by, Jez Humble and Dave Farley, who, really understand how to deliver high-quality software. So let's talk about a couple of these broken out. I mean, some of these are reasonably self-explanatory or well-documented, but coupling and cohesion are always two that are tricky for developers. Coupling is almost always a failure to be solid, and coupling happens when A and B are way too strongly intertwined with each other. And the way that you avoid that, right, the way that you achieve a separation of concerns, which we'll talk about later, is to recraft your software so the bits and pieces are separate from each other. And at the domain-driven design layer, that means that you can define a shared context with DTOs and interfaces in it that version by themselves, and that the other things that depend on them use. And that helps break the coupling. At the coding level, inversion of control helps break coupling and also makes your software a lot easier to test. And I'll point out that if you've watched my channel for any length of time, that I've talked at length about the virtues of queue and event-oriented implementations to make robust systems. And again, if you have events or queues in the mix, they help you decouple A from B. Cohesion. Cohesion is the measure in a component A that all the bits and pieces of component A hang together. In domain-driven design terms, it means that the domain that we've identified and the subcomponents of that domain, each of those subcomponents is an atomic unit of functionality that does one thing and does it really well, acts in solid ways, things like that. And people say, well, how do you figure that out? Well, coupling and cohesion are computed by a number of open source tools, but even more, you can spot poor cohesion by just applying my 5 check. That are all the non-functional requirements we're going to visit in a minute that I've visited on this channel a lot. And that is, if the code is hard to change, it's unmaintainable. If the code is brittle, it's not reliable. If it's hard to test, if it is just a mess of unrelated things, right? Unrelated means poor cohesion. That's supportability. And if it's hard for other people to use, right? People always say to me, what do you like in a good API? And I say, well, if I understand the problem domain, I can just use the API and get the result I expect. And that's a capability, right, that people don't think about. And if we think about how we want to do domain-driven design, irrespective of the implementation, we want to expose services. And those services are APIs, and we want our APIs to be built in such a way that other people can use and get the results they expect. So here's an example of computing the cohesion metric. And I included the original PDF reference way back from 1995. By the way, this hasn't changed a whole lot. The implementations in the various commercial and open source tools vary, right? I mean, people improve the algorithms that compute the metrics, but fundamentally the metrics are pretty useful. So understand that if you read about what these metrics are and then you understand them, when you get the report from these tools, Endepend or CodeMetrics or SonarQube or Visual Studio or whatever, then you'll understand what you're looking at. If you just look at the metrics without understanding how they're computed or what they're really for, they're not that helpful. So taking the time to invest to drill into understanding some of these metrics is a useful thing because they'll tell you things you want to know. Solid was, I think, articulated first by Robert C. Martin, or at least he's the first person in my mind who really pulled it together. And then Michael Feathers took what he did and made the acronym and boiled it down, right? So if you go look at this, at the Solid page on Wikipedia, that's the result of the ideas from Robert Martin and the boiling down from Michael Feathers. And there's a really good book called Clean Code by Robert Martin, and you can go read it and it will explain. But if you aren't really up to date on Solid, you should be, because Solid is complementary to CCAMS and it's also complementary to Stuart's 5 Rules of Happiness. So go learn about Solid if you don't know it. And it's not enough to just watch the video once. You have to live it backwards and forwards as you code. You need to go beyond thinking about Solid to having solid coding practices baked into what your fingers do without you having to think about it too much. That, crawl, walk, run. Know what it is, understand it, understand examples of good practices in your programming language and bad practices in your programming language. And if you put solid practices in your programming language into your favorite search engine, I promise you will find a wealth of articles and posts about, how to implement these things in your programming language. I tend to do a lot of C# and TypeScript. So I'm quite keen that a lot of these can be solved with interfaces and DTOs. I'm also keen on dependency injection, and I'm really keen, as you've heard, on the single responsibility principle. At this point, you're thinking, how on earth am I going to try to fit all this in to my daily beat of trying to deliver products? Well, John Wooden, who's a famous coach, had this saying, and it's true. In the almost 40 years I've been doing this, plus and minus, depending on how you want to count, I have not found any substitute for doing the right thing in the right way right now. And I find that I save myself so much pain down the road, right? There's this famous saying, pay now, pay later. Boy, is that true in software development. And if you don't believe me, go read Barry Bame's Software Engineering Economics, which I've talked about in this. And there are a number of convincing graphs that, say, look, if you don't fix this problem at architecture time or at requirements time, it's going to be monstrously more expensive if it gets all the way into production to fix. So there's something to be said for that. And it's about discipline. It's about applying yourself to live these principles every day and delivering these every day and not letting yourself get pressured into not, I'll come back and clean it up at the end of the sprint, is the biggest lie ever told. Here's my list. A little different than the others because it's a little hard to measure. Some of these are sort of self-contained and others of these, but I break out these 5 things because my personal secret sauce is this list, right? When I am writing code, this is how I tell that the code I am writing is better than not. I don't promise to write perfect code. People who have gone through my GitHub certainly have cause for complaint. I tend to be very bare bones when I code because I've had to write code for embedded systems where you can't just throw in some more RAM or, deploy a bigger cloud machine, right? It's embedded in something that's going to be out in the world. These days we call that IoT programming. Back then we just called it embedded programming. And so I tend to be hyper focused on these things because although 20 years ago, well, 30 years ago, I didn't really have words for these things. These are the things that have floated to the front of my consciousness as I have tried to express to others over the last 10 years, like, what are the lessons I've learned? So testability is a big thing. If you can't figure out how to test the thing you just wrote, the thing you just wrote is awful. We'll talk about the NFRs in a minute, but there are 10 of them, and I have a whole video on them, and you can go watch it. 12 factor. When I write things to the 12-factor specification, I get much better systems. And then documentation is not an afterthought. And my 2 cents on that is documentation is code, is the way to do it. So, for example, if I have a REST API, I always try to leverage a library that will generate the Open API 3 spec in either JSON or YAML, whatever the project requires, because then someone can take that and go write a client or whatever. And I have lots of videos on doing that. But the point is that other kinds of documentation are good too. So C# has XML code comments that can make pretty good documentation using Sandcastle. And NPM has JS doc, so for TypeScript and JavaScript. And almost every decent programming language has some way of generating documentation for your system automatically from the code you write and the occasional spare comments you put in their code. And to me, these are non-negotiable, because if I'm trying to teach a new human the system or parts of it, right, if I have auto-generated documentation, particularly that documentation that interoperates with other machines, that is auto-generated and always up to date, then I don't have to worry about it. If you have a user story that says, update the documentation, you've already failed, because none of these things are an afterthought. If you clean up as you go, your code will never give you woe. I'm going to do a whole video on testability in the near future. Stay tuned for that. So again, here's the summary of the non-functional requirements identified. Again, I have got whole videos on these, but the thesis that we put forward, my little working group and I, was we looked at all the non-functional requirements. We saw that, in fact, there were far too many and that they tended to overlap. By the way, these overlap to some degree too, but we boiled it down to 10, which is still bigger than Miller's number, but it's a reasonable number that you can remember in your head. And when I'm working on the early parts of a project, I often print this slide out and stick it up in my cube or whatever, so that I don't forget to make sure that I have user stories around all of these. And again, these need to be smart, and they need to be testable, or they are not any good. So people come to me and say, well, we're 3 years into this project, dude. We didn't start well. What do we do? Well, C.S. Lewis came up with the answer a long time ago, and that is start today. Every time you merge code into the branch, you should make sure that you did a little of these design principles, hardening factors, code quality standards, whatever you want to call them, that 1, the code that you just wrote conforms to them. 2, that the code that you found in the file that you were editing is better when you check it in than when you checked it out. It's just that easy. And over time, I promise you, your code will get better and better until it gets to a place where your life is better. So the process flow for figuring that out is so that you can give relative value to developers to say, well, if we improve our tests in this way, or we respond to this class of linting errors or whatever, like how to tell what you want people to focus on right now, and then be aware that it's time that this is a never-ending cycle of continuous improvement. Constant and never-ending improvement from the Toyota method. That giving your team guidance when your team is sitting down to think about what would be the best bang for the buck, that you consider this cycle. Small, granular, incremental changes of goodness applied frequently are safer, sure, and less aggravating than doing a lot of big bangs. And I've got a video coming up about that. My name is Stuart. Thank you for your kind attention.